Okay, hopefully you've been keeping up with the work that we've been doing so far. This lesson is only going to be difficult if you allow it to be, and I say that because you already understand what's necessary to get the material done. For example, you've seen this already, 3x plus 8x. If I have 3x's and 8x's, it makes 11x's. It does not make 11x squared. We've learned that. We've had issues with that. We've hopefully fixed those by now. And just so you know, this is what today's problems look like. 3 root 2 plus 8 root 2. And again, notice this is 3 root 2's and 8 root 2's, which means that I will now have 11 root 2's. Notice again, the root does not change, just like the x's don't change. So whenever you add root 2 to a root 2, the root 2 is what's going to stay there, just like whenever you add an x to an x, the x stays. As long as you work that way, you should be okay. If you have an issue with keeping yourselves under control and trying to make sure you understand the rules that I just told you, then it's going to be a long day. But again, a root 2 added to itself stays a root 2. I've got 3 of them here. I've got 8 of them there. I've got 11 root 2's altogether, and that's pretty much what you're looking at. So again, notice that the roots work just like a variable. We only put like terms together just like we only put like roots together. Another example here, I can only put 2x together with 4x to make 6x. I can only put 3y together with 5y to make 8y. That's what we know already, right? So if you take that to what we're doing today, the problems that we have today are going to look like this, where we'll have 2 root 5, 3 root 7, 4 root 5, 5 root 7. I can only put this root 5 with another root 5. 2 of these and 4 of these make 6 root 5's. 3 root 7, 5 root 7 make 8 root 7. Again, the roots stay the same. The only thing you're doing is combining like roots. Just like you combine like terms, you are combining like roots. So again, as long as we convert our understanding of like terms into like roots, everything should be just fine. Unfortunately, the problems won't be that simple. They won't all be that simple. You will have to have at least a basic skill of simplifying radicals to create like roots. Again, basic level. And really what we did last week. So hopefully even if it gets above basic level, you're not too stubborn to ask for help and have me talk you through it. But either way, notice these two roots are not the same. But doing what we know to do, does 12 divide by 4? Yep, 4 times 3, so we can turn, and I would do this off to the side, root 12 turns into root 4, root 3, which is 2 root 3. So this turns into 2 root 3. That still doesn't match. But if we look at root 27, I know 4 doesn't go into 27, but I think 9 goes into 27. Notice that it's 9 times 3, which means that this ends up as root 9 root 3, which turns into 3 root 3. So we can now write this as 3 root 3. Now that we have it in this form, notice that the roots are the same. These are like roots, which means we can put them together. 2 and 3 make 5 root 3's. That is all that you are doing. As long as you know how to simplify, you should be okay. Again, if simplification's been your issue, then you should be asking a whole lot of questions a day whenever you get stuck. But you should at least be kind of getting closer to that because you are smart enough to get it. It's just a matter of whether you've cared at this point to actually try to understand it, but we will see soon enough when everything goes. Again, find the difference of this. 5 root 98 minus 6 root 2. These two are different. Let me try 98 off to the side. So 5 root 98. Let's see what happens. Again, don't ever put your scratch work in your actual work because we're going to work under here. So I want to go over here. 98 can't be divided by 4. And some of these you should kind of know already. 98 can't be divided by 4. Can't be divided by 9. Can't be divided by 25. But it does divide by 49 to make 2. So again, root 49, root 2. So 5 root 49, root 2. Remember the way we do this, we learned that 49 turns into a 7, which when multiplied by 5 turns into 35 root 2. So this becomes 35 root 2 minus, and that's just fine because you can't break down the 2, minus 6 root 2. And so again, these are like roots, just like terms. 35 minus 6 is 29 root 2. Again, your root will stay the same. The only trick is making sure you know how to adjust those numbers to make the roots the same. So that is really the only job that you have today, is simplifying your radicals, which you should have learned last week. Simplify 4 root 7 plus 2 root 28. Just a real quick check, that's a low number. 4 doesn't go into 7, and 9 already passed it up, which means this is going to be 4 root 7. 28 though, I think 28 divides by 4. And it does. 4 times 7, so we're going to go off to the side, write 2 root 28, which is 2 times 4 times 7. Remember that 4 turns into a 2, which multiplied by a 2 makes it 4 root 7. And in the end, like terms, like roots, 8 root 7 is what I should end up with. Alright. And then problem 3 before we get ready to wrap this up. 5 root 32 minus 4 root 18. Again, these two things don't match, so we can't do anything yet. But let's go off to this side and see if we can do anything with 5 root 32. Hopefully you're starting to use your brains more than your calculators. 32 is 4 times 8. So I'm going to do 5, 4, 8. 4, of course, turns into a 2, which multiplied by 5 becomes 10 root 8. I also know that 8 can be divided by 4, which makes it 10, 4 times 2, because 4 times 2 is 8. This turns into a 2, making 20 root 2. 4 root 18. Here's the trick. If I know that this has a root 2, I can just do a real quick check to say 2 times what equals 18. We'll notice that the answer is 9. So it's 9 and 2, because remember that's the special number. 9 turns into a 3, which multiplied by 4 makes 12 root 2. And then in the end, 20 root 2 minus 12 root 2, these are like roots. 20 minus 12 is 8 root 2. Now you can have negative answers. It's possible to have negative answers, but I don't think that you should see many today just because we're getting used to what's going on. But again, hopefully what you see is that the work that I had to do was work that you were supposed to know from last week, so it's nothing really different. It is very important though that you get a solid grip of this material before tomorrow. Otherwise, we're going to include some more operations and it's going to start leaving you behind. I don't expect for you to be perfect today. I just want you to be understanding that you can add 2 roots when you need to simplify radicals. I need you to make sure you start tightening up your simplifying skill and that you understand when you can put 2 roots together. Other than that, go ahead and simplify this answer and hand it in so that you can get your lesson credit, and then you can go on to your Math Excel and get that done. If you finish that assignment, please make sure you're going back and working on other things, because remember that your grade in Math Excel is based off of what you actually do. There is no free credit this quarter, so make sure you are earning what you get, like I told you would a couple weeks ago. Again, this is the 4th quarter. You have to earn it. You got to earn your way out the door here. Other than that, good luck and make sure you're asking for help.